discovery. We are joined today by Amit Shathria, NASA's Associate Administrator, Nikki Fox, Associate Administrator for NASA's Science Mission Directorate, Sean Domagal-Goldman, Director for the Astrophysics Division, and Tom Statler, Lead Scientist for Solar System Small Bodies in the Planetary Science Division. We'll be taking questions from the media on the phone bridge and through social media, but before we get started, let's learn more about this fascinating comet and share some images. Amit, kick us off.
Hi everyone, America leads the way in space exploration. As Courtney noted, a NASA-funded telescope, the Atlas Survey Telescope in Chile, first reported observations of the comet on July 1st, 2025 to the Minor Planet Center.
Vamos ver como é que eu...
And NASA has been tracking and studying.
Deixa eu diminuir a minha carinha aqui. Tá legal assim, será? Ah, internet.
NASA has been tracking and studying Comet 3I Atlas ever since. We're here today to give you the latest of what we know about Comet 3I Atlas and what we still want to know. But first, what is a comet? It's a small, natural, solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star like the sun.
Se a minha live tá dando
I'd like to
certo.
address the rumors right at the beginning. I think it's important that we talk about that. This object is a comet. It looks and behaves like a comet and all evidence points to it being a comet. But this one came from outside the solar system, which makes it fascinating, exciting, and scientifically very important. This is only the third interstellar object like this that humanity has ever found. And a little bit more about the rumors. I think it's very important, and I'm actually very excited that a lot of the world was speculating about the comet while NASA was in a period where we couldn't speak about it due to the recent government shutdown. I think what I took away from that whole experience and watching that as we were working during the shutdown was just how interested and how excited people were about the possibility of what this comet could be. There was a lot of speculation about what it could be, but what I think is really awesome is that folks were interested in this incredible finding that we observed and that came from the heavens, and what that means, what it could mean about how magical the universe could be. It expanded people's brains to think about how magical the universe could be. And I'll tell you,
Ixi, que delay
we
monstruoso.
think that every day. And so it's really great that you were able to join us while we were, not able to comment because of the shutdown constraints about what that comet is, because we think the universe is a magical place, and we spend your treasure and we spend all of our time trying to make sure that we explore that and share with you as much as we can. In fact,
se meu
we
fone
want
carregou.
very much to find signs of life in the universe. In fact, just a few months ago, we were with you and we talked about what we think might be the signal from ancient life on the surface of Mars from our amazing machines that have been roving the planet for 30 years to look for those things.
Oi, você tá ao vivo aqui, ó.
To learn about
É.
and discover it could.
Eu tô fazendo uma live assistindo a live da NASA.
Confirm that, but 3I Atlas is a comet. So my colleagues from the Science Mission Directorate will go through the images in
Acabaram de falar que 13 Atlas é um cometa.
Here's one of the images from the closest physical instrument we had to the comet, from the HiRISE instrument on our Mars Reconnaissance
Não,
Orbiter.
mentira, que essa é a imagem da HiRISE,
The
mano.
comet sailed by at a distance of 19 million miles from the instrument. You can see that Comet 3I Atlas looks like a fuzzy white ball. That ball is a cloud of dust and ice called the coma, which is shed by the comet as it continues its trajectory.
Mano, não, é impossível que essa é a melhor imagem que os caras têm, mano. Não, não é possível, mano. Que porra é essa?
Thank you so much. It is such a rare opportunity for us to be able to observe this interstellar comet. And NASA Science has been given this really, really exciting opportunity to do it, and literally from the moment of its discovery. Just like Amit said, comets are tiny cosmic snowballs, and by studying them, we can learn about the environment from, basically where they formed, where they came from.
Mano,
This one came from a different environment from our own, and so we're already starting to see some really interesting differences.
Mano, é impossível que essa seja a única imagem do HiRISE, mano.
As you heard, is the third known interstellar object to pass through our solar system, the first one being identified in 2017. While these types of interstellar objects have long been predicted, we are just beginning to be able to find them thanks to the newest technologies with our network of Earth-based telescopes, which are designed to find small, fast-moving objects in space. The NASA-funded Atlas Survey Telescope, which made the discovery, is part of NASA's Planetary Defense Network. Our telescopes are always watching the skies to keep us safe, and in doing so, they occasionally make major scientifically interesting discoveries, just like this one. Right away, of course, NASA's Planetary Defense Coordination Office they studied it, and they established that 3I Atlas is not a danger to Earth. In fact, it's at least twice as far away as the distance between the Earth and our Sun.
Mas isso aí também é óbvio, né? A gente nem tá na rota do 3I Atlas, como é que seria um risco? Isso é louco, mano. Esse trajeto é muito estranho, mano. É uma grande coincidência esse trajeto.
Earth was on the opposite side of the Sun, which is about as far away as our planet can possibly be from Mars. It's been clear from the moment of discovery that the comet was going to pass on the opposite side of the Sun from where the Earth is. However, it was also clear that its positioning behind the Sun was going to make observations.
Bom, os caras falaram que é images, né? Deve ter mais de uma imagem, então, porque aquela imagem com nuvem no meio, mano. Por que, mano? Que imagem horrível.
NASA's science assets on board our missions have provided the United States the unique capability to observe 3I Atlas almost the entire time it passes through our celestial neighborhood. Everything NASA science does is interconnected, and nearly 20 mission teams have been working together to really rise to this challenge. 20 mission teams, by the way, and counting. Everything we're learning about the comet is possible because of the distribution of all of the different instruments on our spacecraft with different capabilities. And I'll note that for some of them, we've even pushed our scientific instruments beyond their normal capabilities, beyond the things that they were designed to achieve to allow us to capture this amazing glimpse at this interstellar traveler. In other words, we can study this comet so well because we have many different assets in different locations, observing things in different wavelengths, in different ways, with different instruments, each set of observations providing a different lens for understanding objects in the sky. So NASA's science team has kept watch on 3I Atlas for nearly its entire journey through the solar system for the first time ever. So I'll just quickly go through the timeline of which NASA spacecraft have observed the comet thus far, and we're still going.
Não consigo colocar a legenda aqui, traduzir.
To observe this comet as it continues its journey through the solar system, passing the orbit of Jupiter in spring of 2026. So the NASA assets that are gathering observations of 3I Atlas include Hubble, the James Webb Space Telescope, TESS, SWIFT, SphereX, Perseverance Mars Rover, Mars Reconnaissance Orbiter, MAVEN, Europa Clipper, Lucy, Psyche, personal favorite.
Todas as câmeras apontadas para ele.
Stereo, and ESA, NASA's SOHO mission. And I'll note that Parker Solar Probe's data were just downloaded yesterday, and indeed, we did catch several glimpses of this amazing comet. The scientific community is hard at work analyzing these images, and everyone, as always, is welcome to take a look. At NASA, we embrace open science. We make all of our data available to the public 24/7.
Mentira! Mentira aqui.
To tell us what you're observing and what you think about what we're looking at. We're still learning even about what questions we still need to ask. And this, of course,
eles falaram que eles deixam todos os dados disponíveis para análise 24/7. Mentira, mano. Você vai treinar na academia hoje? Vamos treinar o quê? Bora. Umas 6? Fechou.
So now I'm going to pass over to Sean. He's going to tell you about what our astrophysics missions have seen. They, of course, were some to look at the comet, and images from several of them have been available since the beginning of the summer. So I'm going to ask you to set the stage for us. Tell us what we've already seen before we hand over to Tom to tell us all the new stuff. Take it away, Sean.
Thanks, Nikki. Happy to. To give you some background, NASA's astrophysics missions, like all our missions, they are designed to do things that would otherwise be impossible. In this case, our nation's space telescopes stare deeper and more sharply into the universe than any other observatories in the world. And that means we're often the first to follow up and study near
Mano, os caras
objects
falar
with
isso
comets
e
like
ter
3i Atlas
aquela
after
imagem
their
do
initial
13
debut.
Atlas, mano, é piada,
That
por
same
causa
powerful
que
gaze that lets us
se
these
eles falam
telescopes
que
see
eles têm, sei
distant
lá,
galaxies, those
os melhores
glowing dots you
objetos,
might hear
melhores
about. They
telescópios,
also allow us
para
to observe
detectar o
details
negócio,
about
como que a
objects
melhor imagem
like
não é
3i
deles,
Atlas
e
a
sim
little
de
bit sooner.
astrônomos, tipo,
And the earlier
amadores,
we
tá ligado?
learn about these objects, the earlier we can share this information with the world, including the science community and our partners across the planet that often have ground-based assets or other space-based assets, so that they can conduct additional observations with their telescopes. In this case, our astrophysics missions came together to take advantage of this rare opportunity to study this comet that came to us from outside the solar system. From our flagship space telescopes to smaller missions like TESS and SWIFT, they all have, as Nikki said, different complementary capabilities. They don't just do things that would otherwise be impossible, they do things that even our other great telescopes can't do. So every time we add to the fleet, we add additional capabilities that expand the realm of the possible. In this case, it let us refine the orbit of this structure early on, determine what its structure is and what its composition is, what it is made of. It's a beautiful illustration of why we have not just one space telescope, but a fleet of them, because every one member of that fleet specializes in a different kind of information, contributing a different piece of the puzzle to the total understanding we have.
Os caras
from
poderiam
the
deixar
fleet
as
as a whole.
imagens tipo na tela enquanto
So, for
roda
example,
isso, né, pra gente olhar.
Old Reliable, NASA's Hubble Space Telescope, celebrated its 35th birthday earlier this year. And not too long after that, in July, it looked at 3i Atlas, not long after we discovered it from the ground. At this point, 3i Atlas was about 277 million miles from Earth. And what Hubble's images revealed was a few things. First, a teardrop-shaped coma of dust coming off that solid, icy nucleus of the comet itself. From these data, astronomers were able to more accurately narrow a few things. Importantly, the size of the nucleus. We now know it's between, at that point actually, we knew it was between 1,400 feet in diameter up to as large as 3.5 miles in diameter. And Hubble also saw that the comet was losing dust, and not just losing it, but losing it at a rate consistent with other previous sun-bound comets that originated from within our solar system, consistent with the physics that we figured out from watching those objects.
Será que eles vão falar
The last thing Hubble
da
did is
porcentagem de
it
níquel?
gave us a better understanding of the orbit of this object. Tell us not just where it was, but where it was heading, so we could point other observatories at it, such as the James Webb Space Telescope. We added this to our fleet early in this decade. We didn't have it when the last two interstellar comets came around. And what James Webb did, and its companion Sphere-X, which we only launched at the beginning of this year, is it added infrared observations. The power of infrared observations is, these are colors we can't see. They're redder than what our eyes can detect. And infrared light is particularly good at helping us understand the composition of objects. We can see little molecular fingerprints
O James
from the
Webb
things
ele
the objects
fotografa
are made.
nesse espectro,
So with
né?
these infrared observations,
Que é
with
muito
James
bom.
Webb and Sphere-X, we detected an abundance of carbon dioxide gas in the comet's coma and in the bright cloud of gas and dust surrounding that comet as it approaches the sun. Those molecular fingerprints I mentioned, those are the little like science wiggles you might see in the top right of these images. We now know from seeing those science wiggles, those fingerprints of those molecules, that the comet has a nucleus rich in carbon dioxide as well as the presence of water ice. Now, the ratio, like we can not just say that these things are there, we can also say, what's the ratio of carbon dioxide to water? And we now know that. We know it's larger than what we usually see in solar system objects. But there's a lot of natural explanations for that. For one, the carbon dioxide is going to kind of bake off that comet earlier on when it's far away. But there's other well-understood
Estão se
processes that
contradizendo,
can
porque
also
eles falaram que,
explain.
tipo,
I'll just put this
analisaram
in
muitas
context.
coisas normais e aí vem falar que a proporção era
Every time we
normal,
look
mas que
beyond our
tem
solar
explicações
system
naturais,
and
né?
look at the ratios of carbon dioxide to water, we see, whether it's a star or a planet, different ratios than we see in the solar system, and that's true for this comet as well. So it could mean, and this is the last theory of why those ratios could be different, that these ices could have been exposed to higher levels of
Mano,
radiation
não sei
than
por que
comets in
não
our own
mencionaram
system.
nada a respeito
Or,
da...
as I said before, could be that
Pô,
the
os caras
comet
estão
just
falando
formed
de
from a
proporções, né?
region where carbon
Pra falar
dioxide
se é
ice was particularly abundant
normal ou não, se é
and different
comum ou não.
from
Por que
our
não
solar
falaram das
system.
proporções de ferro e níquel?
Other missions like our
Que é bem
Swift
comum, né?
spacecraft, which
Se
studies
for comparar
X-rays
com
and gamma
qualquer
rays,
outro
have also
cometa.
observed the comet. Teams even looked back through data from our TESS mission, which was designed to look at exoplanets, and found observations of the comet as early as May. That information is helping us understand the comet's history before it got closer and when those other observatories pointed at it once we knew where it was. Now that the comet is near, relatively speaking, our planetary and heliophysics missions have joined in to tell us more. And now I'm going to turn it over to my colleague Tom Statler to talk about some of those new images.
All right, thanks very much, Sean. Before we get started, I just want to remind everybody of where we are, who is where in this play. As you saw in the animations while Nikki was speaking, the sun, of course, is at the center of our solar system. The planets are orbiting around the sun, and in this case, Comet 3I Atlas has come through on a trajectory in the opposite direction and has arrived at its closest point to the sun when the Earth was on the wrong side for us to conveniently observe. But Mars was on the correct side of the sun, and our Mars assets were able to observe the comet, and also several of our other spacecraft were on the correct side of the sun. So the scientific community is really excited about the comet and about these new observations. I'm tremendously excited to help share them with you today. This is a new scientific opportunity, and it's a new window into the makeups and histories of other solar systems. We're just beginning to learn about these types of objects and figure out what are the right questions we should ask about them. Now, let me start by going directly to what we were able to see at the beginning of September, when Psyche was able to see the mission. So before that, though, in August, we organized a workshop. We organized a coordination session for the missions across the NASA fleet that had good opportunities for potentially observing 3I Atlas, so that we could all share observing plans and knew what was going to be possible with our assets. I can't emphasize enough now how, thanks to the cooperation of so many mission teams, we will be accumulating a wealth of data on this comet that the science community will be digging into for years. Now, let's go back to September, and I can show you a sampling of the images collected by our different mission teams. To set the context, you're going to see a comet that's a small body with a coma around it, basically a fuzzy blob. Now remember, space is big. Nothing is ever really as close as you like, and all of these observations are very, very difficult. It's a little bit as if our NASA spacecraft were at a baseball game, watching the game from different places in the stadium. Everybody's got a camera, and they're trying to get a picture of the ball, and nobody has a perfect view, and everybody has a different camera. Now, let's return to September and see the first images
se a
from the
NASA não
Psyche
soltar imagens melhores que as mais recentes divulgadas,
acquired 4 broadband black and white images
não é
of
bom
comet
trabalho,
over
né?
the course of 8 hours on September
Como assim
8th
os caras com todo esse equipamento, todo esse telescópio não conseguem fazer uma imagem de qualidade?
Spacecraft at that time, and you can see in the image the large frame where the comet was seen at different times. Down in the bottom left is a blow-up, a stack in addition of all of those observations. The Psyche spacecraft is on its way to an asteroid in the main asteroid belt that's also named Psyche, and these images were the first captured from this perspective. Now, if you think in that lower left you're not seeing very much, just wait a minute, you'll see more.
Opa,
now, the following week in September, the Lucy spacecraft observed the comet from the opposite direction. So let's take a look at the Lucy image. This is another broadband black and white image
é essa,
made
mano?
by
Dá pra ver nada, velho.
individual exposures that were taken on September 16th. Lucy is on its way to study asteroids that share Jupiter's orbit around the sun, called the Trojan
A
asteroid.
tendência é melhorar, né?
Lucy was
Quando
240
chegar,
million
vai
miles away
mais.
from 3I Atlas, which is circled in
vai
the
ter
center,
uma imagem
when
HD,
its
né? Imagina a melhor
high-resolution
imagem, né?
Lowry
Na teoria.
camera caught the comet. You can see the comet's coma, the fuzzy halo of gas and dust surrounding 3I Atlas, and its tail, a smudge extending to the right of the comet. If you were the Lucy spacecraft looking at the comet from this angle, the sun would be a little bit over your left shoulder, and so the comet tail is pointing away from the sun, as we've seen many times before in solar system comets. For scale, this image spans about 1/3 the width of the full moon as you'd see it on the sky. Of course, at the distance of the comet, that's a much, much larger region of space than the moon. Now, this looks a little different from the Psyche image. Part of that is because the cameras are different, and part is because of the ways the Psyche and the Lucy teams decided to show their images. But also, it's because we're seeing the comet from different directions. seeing a comet's coma in different lighting geometries with the sun coming from different directions is one of the key ways to learn about the physical properties of the dust that's been launched off its surface. And I want to emphasize that you do not get these views unless you have spacecraft farther from the sun than the comet is, so that you can see it backlit. We could not get this view from the vantage point of the Earth. So combining the data from Lucy, Psyche, and Earth-based telescopes, scientists are hoping to better understand
Mano, se isso fosse verdade, como que a gente tem imagens tiradas da Terra que são melhores que as imagens de fora?
To compare ancient dust from a distant solar system to that from our own. Now let's go to the next picture from the Maven spacecraft at Mars.
Tem muita coisa que eu, na minha opinião, acho contraditória que eles estão falando. E tem muita informação que eles não estão divulgando, né? Informações importantes e relevantes.
Ahmed shared from our Mars Reconnaissance Orbiter. Maven is another Mars orbiter that has been studying the Martian atmosphere since 2014. Now, this picture is not a direct picture of the comet itself. It's a spectrum. You're seeing the science wiggles that Sean was just talking about. This is some of those science wiggles where the instrument, the spectrograph, the ultraviolet spectrograph on Maven has looked at the comet and also split up the ultraviolet light according to color. So you're seeing three different bands in this image. On the right, you're seeing emission from hydrogen gas in the atmosphere of Mars. In the middle, there's a fainter band indicating that's coming from hydrogen gas in interplanetary space. And on the left, that blob is the signature of hydrogen gas coming from comet 3I Atlas. It's a little blob rather than a big streak because the comet is a small object in the sky relative to great big gigantic Mars and interstellar space that fills the entire field.
Mano, eu não sei porque eles estão toda hora afirmando o pequeno, o 3J, sendo que ele é o maior objeto que eles já
But it's
passou.
also telling us it's one of the many ways that we're able to discern the chemical composition of 3I Atlas. And in this particular example, it's showing us the hydrogen gas that's coming off of the nucleus. Now, Maven's observations, combined with the earlier observations by Swift and Webb that Sean spoke about, will help determine the water production rate, how much water vapor is released from the comet when the comet is warmed by the sun, which provides insight into the formation of the comet and its journey through our galaxy. Now, the European Space Agency and NASA's Solar and Heliospheric Observatory, or SOHO, also successfully imaged 3I Atlas from October 15th to 16th after it had passed Mars. And SOHO spotted the comet crossing its field of view from approximately 222 million miles away, or more than twice the distance of Earth from the Sun. Comet 3I Atlas was expected to be too faint for SOHO to see, but this result was made using detailed image processing and overlaying, or we call it stacking, subsequent telescope images. And this image highlights the value of spacecraft and instruments designed to look directly toward the sun, as Nikki was saying before, not only to study the sun, but also to have the ability to see other objects crossing, in this case, behind the sun from the telescope's point of view. You'll be able to see the rest of the images on our 3I Atlas website, go.nasa.gov/3I-Atlas. And there will be more to come. Not all of the data have been downlinked yet through NASA's Deep Space Network.
Mentira, que eles vão acabar
And also, it's a long way from where we are today, seeing the initial images, to then making sure that they are accurately calibrated and processed to do science with, and then doing the analysis, combining the data sets, understanding them, and finally producing the scientific understanding, the knowledge of what this all means, which will be published in peer-reviewed scientific journals. The answers will come later on. We are still at this phase, very much in the state where we're figuring out what are even the right questions to ask about interstellar objects. This is a snapshot of where we are very early in the scientific process. Okay, back to you, Courtney.
All right, thank you all for your opening remarks. We'll go ahead and start the question and answer portion of this event. Just a reminder to our media on the phone bridge to press *1 to enter the queue and ask your questions. We'll take our first question from the phone bridge from Marcia Dunn with the Associated Press.
Yes, hi. Based on your latest observation, what more can you tell us about the potential shape of the comet? Can you fine-tune any more on how big or small it might be, origin, all that sort of thing? Thank you.
Thanks for that question. There's a lot of territory to cover there, so let's see what I can do. The size of the nucleus still has yet to be pinned down. The best data are still from the Hubble observations that Sean was talking about. So we're still right now in that range of somewhere in the vicinity of a couple of thousand feet to a couple of miles diameter, but we'll get better on that one. The shape of the nucleus is also difficult to pin down because generally we're not resolving it in our observations. It's obscured by the dust, and especially it's obscured by the reflected sunlight off of the dust in the inner part of the coma. But what observers from the ground have been able to do is observe the brightness of the center of the comet over time to see if there's a modulation of that brightness that would be an indication of rotation. And it's very difficult to discern. So what it's looking like so far is that there's not a big, the shape of the nucleus is not very far from being round. It's not, doesn't seem to be a big, or at least we're not seeing signatures of a very elongated object yet. There's a lot still to come there. I think you were also talking about origin. It would be great, it would be fabulous if we could trace back the incoming trajectory into the solar system and trace that back and figure out where it came from. But things are not quite so simple. Our galaxy, as Sean knows, is a big and complicated place. And the sun and all the other stars in our galaxy are in orbit around the center of the galaxy. And so 3I Atlas has been in interstellar space for a very long time. There is circumstantial evidence, given how fast it has come in to our solar system, that it came from some very old population, of solar system around a very old star. Quite possibly, we can't say this for sure, but the likelihood is it came from a solar system older than our own solar system itself, which gives me goosebumps to think about, frankly, because that means the 3I Atlas is not just a window into another solar system, it's a window into the deep past, and so deep in the past that it predates even the formation of our Earth and our Sun.
Isso é da hora mesmo.
All right, we'll take our next question from the phone bridge from Bill Harwood with CBS. Bill, if you're talking, we can't hear you.
Try me again. This is Bill Harwood again. Can you hear me?
We have you loud and clear.
Okay, thanks. Sorry about that. Amit mentioned the rumors that were, kind of scurrying around about this thing in the weeks leading up to this briefing today. I have two questions for anybody who would care to answer. One is, did any of you seriously, did you take seriously the proposition from some that this could be an alien spacecraft? I doubt you did, but I'm asking the question anyway. Two, is there any evidence you see in any of the data you have that would fit an explanation like that? Or as far as you're concerned, does all of this data say conclusively that this is simply a comet that happens to be passing through the solar system? Thanks.
So I'll take that one, Bill, and thanks for the question. We love all of the different science and all of the different kind of hypotheses into what these things can be. When you start seeing something, you just got a point. It's natural to wonder what it is. And we actually love, as Amit said, we love that the world wondered along with us. And that's such a cool thing. We certainly were able, because of the measurements that Sean described from the astrophysics telescopes that immediately turned on this object once we found it. And even, I was interested, I just learned that we'd actually gone back and actually seen it before we even found it. So that was super cool. I just heard that from Sean. But, we were very quickly able to look for sort of, the easiest thing to do, I'll put it in a different way, is if you understand comets pretty well and you understand asteroids pretty well, you kind of know the signatures that you're looking for, and so you can sort of look for those quickly and tick them off and say, yep, it really does behave like a comet. The interesting thing that, Tom, I know if I throw this to him in a second, he's going to geek out about it. But the really cool thing about this is the differences, because it comes from somewhere else. And that's why we're so excited about it. It's only the third time that we've been able to identify and track something coming from outside our own solar system. We've long predicted these things occur, and now, of course, we know better how to look for them, and we now have this amazing Atlas array. We're expecting we'll find a lot more of them, but it was quick. We were quick to be able to say, yep, it definitely behaves like a comet. We certainly haven't seen any technosignatures or anything from it that would lead us to believe it was anything other than a comet. But the super cool thing is not that it's exactly like all the comets that we see in our solar system. It's the differences that are so tantalizing for us as it gives me goosebumps too. It could be from something that existed before our own solar system. That is so cool. It's from something that predates even our own star. Yep, it's going to look different because it didn't come from our solar system, and that's what makes it so magical. You want to geek out a little bit, Tom?
You were geeking out so expertly, Nikki, to begin with. So that was fabulous. But that's exactly right. I mean, things from other places, we naturally expect them to be different from our own homegrown variety. And I like to imagine if you're fortunate enough to have grown up in Hawaii and you only drank Kona coffee, you love your Kona coffee, and then somebody says to you, well, gee, have you tried Sumatran? You're going to say, well, do you expect it to be different? And they'll say, why don't you try this? And you try it and you say, wow, that's really different. And you realize, well, I expected this to be different because it was from someplace else. It was a different environment in Sumatra. Now, does that one sip of coffee tell you everything about the weather in Sumatra and the soil and the people who harvest the coffee? Bless them. Of course not, but it's different, and yet it's still coffee. And that's what we have in this case. We have a cometary body. It resembles the homegrown comets that we have in our solar system.
Composição do café é diferente, né? Você não tem o mesmo princípio, você tem moléculas diferentes. Não dá para chamar de café, né? E no caso do 13 atas é isso, né? Se você tem uma porcentagem muito alta de níquel, maior do que a de ferro, você já está olhando para outra coisa.
Evaporate dust, and the dust is broken down. The minerals are broken down by the ultraviolet light of the sun. And comets, we know comets put out nickel, they put out iron. That's what comets do. This particular one is putting out more nickel than iron. That's really interesting, really remarkable, and something to be studied in the future. So we're always interested in new ideas. We're always interested in new suggestions, and all ideas are good when they're born. But those that stand the test of time, those that stand up to testing, those that are supported by the evidence, are the ones that survive.
All right, we'll take our next question on the phone bridge, and that one comes from Matthew Glasser with ABC.
Good afternoon. Thank you for doing this. Tom mentioned that the answers will come in time. I'm curious about what are some of the hopes that we might discover from this comet. What might it tell us about our planet, about our solar system, about the universe? Are there key things you're looking for as you start to analyze this data, and are you excited about anything in particular when it comes to better understanding how things are working out there?
Sure, I can take that. Every new object we discover is a new piece in the puzzle. What we're trying to do always is to understand the universe. That's part of the NASA mission, is to understand the solar system, understand the universe, understand the origin of planets, the origin of life. And that is a huge question, and we get little bits, little clues to parts of that puzzle, and we start trying to put that puzzle together. We have gained tremendous amount of information from hundreds of years of astronomical observation and from decades of in situ spacecraft observation has revealed our planets as actual places, not just points in the sky that you could barely see with your own eyes. We've learned about comets and asteroids, and we're beginning to put together a picture of how all of those planet-forming minerals and planet-forming ices came together to form our planets, and how our solar system changed over time. Just one example, we get a fascinating clue from the objects like Pluto that we've been discovering since the 1990s, the trans-Neptunian objects, the way they are distributed through space